Welcome everyone. In this video we'll look at a Year 2 A-Level Chemistry exam question on reaction rates. Details are in the description. We will be given a table of experimental results. This table shows how rate of reaction is impacted when the concentration of reactants is changed. I'll show you how to work out the rate expression, often referred to as the rate equation. Let's get started. Here's the question. Show how these data can be used to deduce the rate expression for the reaction between A and B. There is an order of reaction with respect to each reactant. Order of reaction details how the rate of a reaction will change when the concentration of a reactant is altered. Order of reaction can be 0, 1 or 2. Assuming all other concentrations are constants, if the concentration of A is increased by a factor of x and the rate does not change, the reaction is 0 order with respect to A. For example, if the concentration of A is doubled and the rate is unchanged. If the concentration of A is increased by a factor of x and the rate also increases by a factor of x, the reaction is first order with respect to the concentration of A. For example, if the concentration of A is doubled and the rate also doubles. If the concentration of A is increased by a factor of x and the rate increases by a factor of x squared, the reaction is second order with respect to the concentration of A. For example, if the concentration of A is multiplied by 2 and the rate is multiplied by a factor of 2 squared. First, look for two experiments where the concentration of only one reactant changes. From experiments 1 and 2, the concentration is multiplied by a factor of 3. The concentration of B is constant and rate increases by a factor of 3 squared. Therefore, this is second order with respect to the concentration of A. Finding the order with respect to the concentration of B is tricky. The concentration of A is not constant in any of the experiments. We know the order with respect to the concentration of A. We need to use this to work out the additional impact of changing the concentration of B. From experiments 2 and 3, the concentration of A is multiplied by 2 and the concentration of B is halved, multiplied by 0.5. The rate is multiplied by a factor of 2. The effect of doubling A alone would increase the rate by a factor of 2 squared. The rate is only doubled. Halving the concentration of B halves the rate. Therefore, this reaction is first order with respect to the concentration of B. Remember, we had to show how these data can be used to deduce the rate expression. Here's the answer in full. The rate expression is rate is equal to K multiplied by the concentration of A squared multiplied by the concentration of B. K is called a rate constant. Thanks for watching. Please like, subscribe and hit the bell for notifications. Post in the comments if you have any questions or suggestions. Take care and good luck with your studies.